Okay, good day everyone. So today we'll be talking about Newton's laws, and underneath we'll have a subtopic which is the normal force. This is the only force that we'll be focusing on. This is the force that we'll be focusing on. So let me explain. Let me give a brief intro of what is exactly a normal force. A normal force is a force that is in contact with the surface and mostly opposes the force due to gravity. It is always opposing the force due to gravity. Okay, let's say for example, I have maybe I want to make a good scenario right now. I want to make a good scenario. Um, let's say I have my hand here on the table. Because my hand has mass, it means only there is force of gravity acting, because force of gravity is due to the mass of an object. But there is also a normal force acting in this hand, because it is in contact with the surface. Therefore it has to oppose the motion, or it has to oppose the force of gravity. So let me make an example, because this is the only force that give learners a big problem. Let's say I have a box on the surface. This box is 5 kg. Let's say this box is moving to the right, and then there's also friction here. There's also friction. So they say draw a free body diagram. My free body diagram will be written like this. First I will check the given forces. I have the force applied, which is Fe, and then I have the force which is friction, that is opposing. Fk is opposing the motion of an object, and then I have force of gravity, which is Fg, that is the weight, and then I have my normal force, which is F. I have my normal force right there. This is how you actually illustrate this, but it seems quite simple right here before we have our components and stuff. But okay, what do I do? I don't claim this. I don't claim. I just know what is actually going on behind each diagram, because in most cases they won't give you this type of diagram, especially for grade 11 and especially for grade 12. They don't give you this. And even on grade 11 during exams they won't give you such. It's simple. It's simple. Then let's go to subtopic. Let me do this subtopic A. I'll just do horizontal. I'll just name this horizontal. Then B, I'll write this incline. I will call this incline. It's when it is on the incline. Then okay. We don't cram. Relax. I have my box right there, which is still 5 kg. And then there's an angle here which is, let's say, 20 degree. But there's a person here. I'm not good at drawing, so I won't draw the person, because obviously you're gonna lose focus right now. I know you're gonna lose focus when I draw. Let me try. By the way, there's a person here, and that person is pushing the box right there. This person is very nice. Looks like possibly like one of my followers. Okay, that person is pushing the box up the incline, and they told us, or no, there is friction. In most cases they say rough surface. As long as there's friction, man. That's how you flow. Rough is friction. You just flow. You don't ask yourself, because you only have 3 hours to complete the entire paper. In fact, you have 2 hours to complete the entire paper and an hour to revisit the entire paper. Yeah. Okay. So first of all, I will draw the free body diagram. I'll just draw the free body diagram, and then my free body diagram will go like this. Listen carefully. Force of gravity always goes down. It doesn't change. It is always going straight down. Just take it that way. Always going straight down. This is the force of gravity, always going straight down. Then I get this is my Fg. This is my Fg. Then I have normal force. How do I actually write my normal force? You can't actually draw a good normal force right now, unless you are part of those students who want to pass with 10, 20. Because even someone who's aiming for 30% won't do such a thing. Then secondly, you write secondly you write the force applied. And this person is pushing the block like this. The force applied will be going something like this, something like that. And then and then friction will be pulling the block down. Friction uzoba apula a block down. Don't mind me, I'm actually learning isi Zulu, so you have to yeah, you know, because it's nice in here. There's friction, this FK, and I will first apply, and then I have my normal force. I said normal force is always in contact with the surface and always there, listen, and always opposing the force of gravity. But someone will be asking how I drew the normal force, ne? Okay, normal force uzohamba kanje. Hey, ngiyakhuluma guys, ngiyakhuluma. If you are moving here, I feel sorry for you, my guy. Man, they don't manage. Okay, this is how my normal force is. And someone say, yo, how is this going? Like, where is this going? You just shifted your logic, or normal force is always opposing. Okay, listen. This is the very part where we have the components. We have our components. Listen, we have our components. The first component is the component of weight, the gravity, which is the Fg, not Fg Yamatari or Fg, that one of making tea. No, I'm talking about Fg, which is weight perpendicular. This is the weight perpendicular. And then I have another component, which is the Fg. Our Fg, Fg parallel. Fg parallel. You know, or if things are parallel, we'll write like this, and mathematically we do this. But here we will just write about double slashes. This is Fg parallel. So bona fit, bona. Now my normal force, this arrow is not that straight, but whatever, as long as you understand, then the normal force right now is actually opposing Fg perpendicular. About Fg perpendicular. Like, I haven't got there, man. I missed something, but fine. I'll edit. There is an angle. Someone asked, where do I write an angle in this case? No. Don't panic, guys. Don't panic. The angle is always adjacent to Fg perpendicular, meaning the angle will lie here. Yeah, but always adjacent. Ori, it must be lying, or it over there. It has to sleep on Fg perpendicular. That's it, man. That's it. Don't confuse anything. So yeah. If you want to make a triangle, the science is nice, man. Science is nice. You are constructing a triangle. Doesn't matter which arrow goes where. I'm just making a triangle right here to illustrate. No, in fact, I should have written it while explaining. Okay, first of all, we're gonna take one force among, like, I'm making a triangle which only involve weight, ne? So what you will do first is, maybe you take, people always love things on a straight line. So the first arrow will be weight parallel. This Fg parallel. And Fg parallel is like this, ne? Meaning, there's also, let me do this. These two lines are in parallel. Meaning, you can either write it like this, because they're in parallel, and parallel lines are equal mathematically, and we are doing it scientifically. And then this Fg parallel, and then we have Fg. This is the main Fg, and then we have no, this is not it's Fg perpendicular. Sorry guys, this one, which is like on a straight line going in opposite direction with the normal force. And then we have Fg, the main is always upward. Fg is the hypotenuse. So where do I put 20 degree? This one always adjacent to Fg perpendicular. This is where I put it. So dango sharp. Okay, how do I find my normal force? Because this is the main focus of this video. When I said I missed something I was talking about here, what I mean is the normal force is, I'm working on this vertical line. It will be F net equals to MA. And then I want you guys to listen carefully. in Newton's law, we only deal with two types of motion. It's either horizontally or vertically. Horizontally or vertically, horizontally or vertically. So this is my horizontal motion and this is my vertical motion. Normal force is involved in vertical motion, and vertical motion only involve those two forces, which is Fn plus Fg equals to, because this thing is moving on a straight line, it is not shifting up and down, it is going in a straight line. It means the up and down motion is constant, and the same moment I say something is constant, it means it's not going, it's not moving in that direction, because the acceleration is unchanging. I don't know if you guys can hear what I'm trying to say. Let me make a scenario. You see my rubber here, it's moving horizontally, it's not going up and down, meaning the up and down motion is constant, it is not moving in that direction. Listen, let's make this simple, meaning the acceleration for up and down motion is constant when we are focusing on the horizontal motion. If you guys don't get it, repeat and repeat until you understand what I'm trying to say. Meaning, if the acceleration is constant, then the F net will be equal to 0, and then normal force. Here, remember, I have to choose direction. Let's say I chose upwards as positive. Meaning normal force is going upwards, then force of gravity is going downwards. It will be minus G equals to 0, meaning normal force equals to Fg right there. That is my normal force. My normal force is actually equal to what is Fg equal to? Mg, something like this. This is the weight. Normal force equal to weight in this type of motion. But in this one where there is incline, it's something different. So I will do this. Again, it is going up the incline, not up, it is going horizontally on the incline, not vertically, meaning it will be F net equal to MA. Let me just write MA. Then you go to a diagram and ask yourself, the free body diagram, what are my
incoming error?
My vertical forces. The first vertical force is Fn plus Fg.
There is no Fg. Because force of gravity is broken into components.
And the rest are going horizontally, and then it's equal to M.
Mistake corrected.
Remember,
at the end of video.
To choose direction, I chose upwards as positive, Fn, and then minus Fg minus Fg perpendicular equals to 0. Guys, maybe you guys have forgotten listen, maybe you guys have forgotten if I have a triangle, I can break out into our course, sine, tan. That is when I'm working with physical science. So focus on this diagram. Don't get confused, guys. Don't get confused. Angiti, Fg equals to Mg, because this actually weight equals to Mg. Maybe you guys know it this way. There. My angle is adjacent to Fg perpendicular. Fg perpendicular. My angle is adjacent to Fg perpendicular. Meaning, if I want Fg perpendicular, what do I actually say? I say adjacent, which is Fg perpendicular, over what is my hypotenuse? Fg equals to cos of 20 degree, and Fg will be equal to Fg cos 20. This is it right there. And then if I want my Fg parallel, I will say opposite, because this one is opposite to that angle. Opposite over hypotenuse. I'm not sure if okay. Opposite over hypotenuse is equal to sine 20 right there, and then Fg perpendicular equal to Fg sine of 20 degree right there. So I'm going to substitute these things, okay, and then normal force will in this case will be equal to Fg my plus Fg plus Fg cos 20 degree. And I said Fg parallel is equal to Fg cos of 20. That is meaning that is my normal force right there. That is my normal force right there. And then I won't do much because I'm taking a lot of time in this one. And then my third scenario, which is C, will be components of forces. This one should have been my second, but sorry about that. I think I'm a bit. This is my 5 kg block, by the way, and the force applied is applied at an angle, which is FA, and then this one right there, it's applied at an angle, but someone is actually pulling it that way, when maybe you are pulling something on a rope, let's say crate or something on a rope, there should be an angle. Oh, I wanted to draw an angle, by the way, sorry, this is my 20 degree. Then Vari, let me draw. I'm not sure what I can name this guy, but something like Wasi Ponyana, so because I was they're always smiling at it. I'm not sure. I have to draw my free body diagram, and there's a rough surface, guys. There's a rough surface, but it doesn't matter about the surface because that's not mainly our focus. So they say draw the free body diagram. My free body diagram will be weight Fg, and we'll have friction Fg. No, Fk, man. It should be Fk, and then this one is applied in an angle Fa. Okay, there's also normal force. Normal force. I know the moment you say something is normal, people get happy, but when you say you're not normal, we say a lot of things, man, and a lot of words. Okay, so mamela apa ngiyakhuluma. Okay, I will break it into the components of force. This force applied is applied at an angle, meaning there are components. The first component is the horizontal component, which is Fx, and there's also a vertical component, which is Fy. All right, guys. So what is actually, I'll be quick here. What's actually my normal force? Ish. We see a lot of things in this case, man. Ish. I said, when I'm looking for normal force, I mostly focus on my vertical motion. Unless maybe I'm talking about that formula of Fk equals to mu k of the coefficient of what times normal force. This is where I can even consider Fk, but in this case I'm considering the vertical motion. So I'll write F net equal to ma, and then my normal force I have Fm, and I have plus Fg, which is going downward, plus what am I? In this case I'll be taking the components, right? Because here I was also considering I make a big mistake. Yeah, I just realized here, I involved I just realized I involved this one. It wasn't supposed to be involved because I'm using the components. See, there isn't. I never like our components at school because I know they can be terrible sometimes. I forgot AMA components. I forgot I'm using AMA components. Fine. Okay. This ruined my nice video share. Okay. Here I will consider UFG, and then I won't consider this FA because this very same moment I break it into components, I won't be using this one anymore. Listen, Jambori, I will also consider FY. Then I think I've become so useless nowadays. Okay, plus Fn, and get Fn is going upwards and Fg is going downwards. Fg, and then plus Fy equals to 0, and then Fy is actually, and here we have the 20 degree, and so Fy is something like here, meaning it is opposite, right? It is opposite the angle, meaning Fn equal to Fg minus fy, and then what is actually fy equal to? Is equal to f a sine 20 degree. That is my normal force right there. So let me revisit the previous calculation where I made a mistake. I will just make a brief summary because it's a little mistake that I did on my FNet. Because I broke the FG into components, meaning I will not be considering this the actual FG. I will be considering FG parallel and FG perpendicular, meaning I have on my up vertical forces I will have UF n plus FG perpendicular, and then here I said I'm taking directions, and then FNet is going upwards and the FG perpendicular is going downward, meaning it will be FG minus FG perpendicular equal to 0, and then thank you, even though I made a mistake, but yeah,